Right, now that we know how to factor polynomials, we are going to factor 7 different polynomials in no particular order. And we're going to follow our outline. So the first polynomial is 12x squared minus 12x plus 3. So the first step is to take out the greatest common factor. Well, my greatest common factor is 3. And so I'll have 4x squared minus 4x plus 1 left. The second step is to identify my polynomial. Is it 4 or more terms? No. This is a trinomial. In the trinomial, I have 3 categories. Is the leading coefficient 1? Well, I could turn it around and the leading coefficient would be 1. Is it a perfect square? Well, the first term is a perfect square. The last term is a perfect square. But the middle term has to be 2 times the square root of the first term, which is 2x. So 2 times 2x. Times the square root of the last term, which is 1. So is the middle term 2 times 2x times 1? Well, yes, it is. So this is a perfect square trinomial. And I'm going to factor it that way. Now, the factors of a perfect square trinomial are identical, and they consist of the square root of the first term and the square root of the last term, and you put the sign of the middle term in between them. Since they're identical, I can just put a squared up here. All right? Now, here's a particularly difficult trinomial to factor. X squared over 8 minus 7x over 4 plus 5. This trinomial does not appear to have a greatest common factor, but it does have an issue. It has these different denominators in it. So in order to make the factoring easier, I'm going to get common denominators for all of these terms. Now, the least common denominator for 8 and 4 is 8. So the first term stays the same. The second term, I'll have to multiply the numerator and the denominator by 2. So I get minus 14x over 8. And the last term, I'm going to have to multiply 5 times 8 over 8. So that's going to be 40 over 8. Now my pattern has an 8 in common, but it's in the denominator. So when I factor that 8 out, I will put it in the denominator. And then I have x squared minus 14x plus 40 left. All right, identify my polynomial. What's a trinomial? And the leading coefficient is 1. So I'm going to factor it like we factor trinomials whose leading coefficient is 1. So there's my 1/8. And then x will go here because it's the square root of the first term. The last number determines what goes here. My two numbers here have to multiply to give me a positive 40 and add to give me a negative 14. Well, 4 and 10 multiply to give me 40, and they add to give me 14, so I'm going to make this minus 4 and minus 10. Here again, it does not matter if you write the x minus 4 first or the x minus 10 first. All right, let's factor some more. 8a squared minus 18. All right, take out the greatest common factor. Well, my greatest common factor is 2 this time. And so I have a 2, and then I have 4a squared minus 9 left. All right, now my polynomial this time is a binomial, and it is a difference of 2 squares. It has to be a difference of 2 squares or I cannot go any further. This is a difference of 2 squares. 4a squared is a perfect square. 9 is a perfect square. So my binomial factors into 2 factors that are almost identical. 2a and 3 sit in these spots, but then one of them will have a minus sign and the other will have a plus sign. You just put the square root of the first term in the first place, the square root of the last term in the last place. Here again, it does not matter what order those are in. Well, let's do another binomial. 15x squared minus 6x. All right, take out the greatest common factor. Well, I have a 3x in common with both of these. So when I pull the 3x out, I have 5x left here and minus 2 left here. Now I identify my polynomial. Well, my polynomial is a binomial. Is it a difference of 2 squares? No, it clearly is not. So I am done. All right, let's do another trinomial. 18x squared minus 9x minus 5. Take out the greatest common factor. Well, this trinomial has no greatest common factor. Remember, your greatest common factor has to be something they all have in common. All right, so now identify my polynomial. Well, it is a trinomial. Is the leading coefficient 1? No. Is it a perfect square? No. 18 is not a perfect square, neither is 5. So it's just a generic trinomial. Remember that to factor generic trinomials, we multiply the 18 times the negative 5. We get negative 90 in this case. And we look for pairs of numbers that multiply to give me negative 90 and add to give me negative 9. For example, 9 and negative 10 multiply to give me negative 90, but they add to give me negative 1. Negative 9 and positive 10, the same. They add to give me positive 1. So those aren't going to work. What about 45 and 2? Well, I've got 45 and negative 2, negative 45 and positive 2. But when I add these, I still don't get negative 9. Let's try 6. All right, 6 times 15 is negative 90. Well, it turns out that 6 minus 15 is negative 9. So this is the pair of numbers that gives me my middle term. So I'm going to use those to rewrite my trinomial in 4 terms instead of 3. So instead of having negative 9x, I'll have plus 6x minus 15x and then minus 5. Now it's 4 terms I can factor by grouping. So I group the first 2 terms together and the last 2 terms together. All right, well, the first 2 terms have a 6x in common. Well, I pull the 6 out, x out. I have 3x left here and plus 1 here. And then the last 2 terms have a negative 5 in common, so I pull out the negative 5 and I have 3x plus 1 here. Right, these are exactly alike. They have to be exactly alike in order for me to move forward. So I'm going to now factor out the 3x plus 1, which is the greatest common factor between these 2 terms. And I will have 6x minus 5 left. So I have factored my trinomial. We're going to do a couple more. Two xy minus 6x plus 3y minus 9. All right, take out the greatest common factor. Well, I don't have a greatest common factor. Some of these terms have one number in common, some another, but I don't have a greatest common factor. All right, so I identify my polynomial. Well, my polynomial is 4 or more terms, so I factor by grouping. Now, remember that there are several different ways you can group, and they don't always all work. So if one way doesn't work, then I can try another way. I'm going to try these, grouping them first 2 and last 2, and see how far I can go. All right, the first 2 terms have a 2x in common. So I'm going to take out my 2x, and I have y minus 3 left. And the last 2 terms have a 3. Remember to always put a sign in front of the number that you take out. And then I have y minus 3 left. These 2 factors are identical, so I can move on to the next step. So I take y minus 3 out, and I have 2x plus 3. And I have factored my polynomial. Now here's one more, and this one is a polynomial with a pattern. All right, now in this it looks like a trinomial. It looks like a trinomial pattern. This polynomial does, and I can factor this by multiplying all this out and combining like terms, and then proceeding to go through my little chart. But if I can see the pattern, that usually makes it easier. And there are some polynomials that you cannot factor if you cannot work with the pattern. All right, in this case, I can see a trinomial pattern going on here. I have something squared, I have that something to the first power, and then I have a term where that something doesn't exist. So what I'm going to do is I'm going to let a equal that x plus 4. And everywhere there's an x plus 4, I'm going to put an a. So I'll have a squared plus 2a minus 8. I put a in for this x plus 4. I put a in for this x plus 4. And then I have my minus 8. Well, now it looks like a trinomial. And the leading coefficient is 1. So I would factor this trinomial as a and a And the two numbers that multiply to give me negative 8 and add to give me 2 are positive 4 and negative 2. So I put a positive 4 in here and a minus 2. Alright, now I could quit here except that I really didn't have a in the original problem. I had x plus 4. So I need to resubstitute the x plus 4 back in for the a. So this is really x plus 4 and x plus 4 minus 2. Now once I've done that, I just need to clean it up. So this is x plus 8 times x plus 2. These cannot be factored any further, so I am done.